Hello, my name is Jefferson Ridgway, and my non-European mathematics group is called the Arabic Mathematics. And in just introducing these people, before Arabic mathematics came to be, it was the Greek mathematicians and what they founded and what they created which was really what drove the world of mathematics to this current point. And this current point was really called the Islamic Golden Age, which incorporated the House of Wisdom and other factors in it. So when we think about Arabic mathematics, what do we think about? Well, in doing my research, I found that they were the first to use a number system that included zero as a placeholder, as well as understanding where algebra comes from, where algorithms comes from, and just all these other mathematical concepts that now we use today, even 2016. So understanding that, I want to talk about one of the leading pioneers in Arabic mathematics, and that is Muhammad al-Karamzi. And his name literally translates in Latin to algorithm. And he had a couple works, and those couple works, there were various works, but there were really three that were really prolific in his lifetime. And one of them was called The Compendious Book on Calculation by Computation and Balancing. And from that whole title and from that whole book, you get the word algebra. And the second book he had was called Al-Karamzi concerning the Hindu art of reckoning. And in this book is where he found the number system that we now have, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So understanding this, what he found was very prolific and very revolutionary for his time, because before Arabic mathematics, people didn't have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They only had 1, 2, 3, 4, 5, 6, 7, 8, 9. So just having that zero placeholder in that position was very monumental for that time period. And his third book was called The Image of the Earth, which literally translates into geography. So in understanding that, he wanted to know, he was very into geographical concepts as he was mathematical concepts. And in this book about geography, he was trying to find the circumference of the earth with another pioneer in that area of science as well. The interesting fact that I learned about Muhammad al-Karamzi was that he was very practical in his mathematics. And one of his intros to his book, he talks about how he wanted to use mathematics and the knowledge that he learned to actually help people in a day-to-day task. And that was very interesting to me, because when people tend to think of mathematicians, even myself, I think about people who are very theoretical, have great theories and like crazy, just foundational theories. But when it comes to practicality, outside of finances and business, I don't really see the mathematics. But he even said that he wanted to help people, whether that be in their inheritances, the allocations, sharing their allocations, engineering, equipping, digging canals, just any and everything. He was trying to use the knowledge that he had gained or that he had found to propel the society forward as a whole. And I just think that was very ingenious, because he was able to just again use what he learned to better and benefit the society he was in, not just to keep the knowledge for himself or to pass around the knowledge to other people who understand it, but to actually apply that knowledge to practical things and issues. And another thing that I learned about the Islamic Golden Age, and in particular Arabic mathematics, is the fact that there were women in there that were involved too. And I think that anytime we talk about a group of people, a cultural group of people from history, we have to understand it was not always men who advanced the society, it was women too. So I wanted to shed light on those women, and two of those women that I found out were Satari al-Muhammadi and Laban of Cordobana. Forgive me for butchering these names. And these two women, one was very great at calculations and calculating things, and another was very great or good at just advancing algebra to its furthest lengths in that time period. Another pioneer who was not a woman was Muhammad al-Karaji, and he introduced algebraic calculus as well as the proof of mathematical induction, or as we know it today as PMI. So he introduced those things. Muhammad al-Karamzi introduced algebra, algorithms, geography, and these two women introduced further these calculations and further algebra during that time period. So what you see is a collective of individuals, including more individuals that I did not name, that are now just advancing society to its fullest potential where it can be at. And sadly, with each flourishing of each society and civilization that you see in history, there's always a decline in that civilization. Um, and the decline of this was due to the Mongolian Empire coming in and killing a lot of people, a lot of the scholars, and not just the killing, but just people leaving the area. And basically, what this area was called the Islamic Golden Age, or in particular, it was called the House of Wisdom. And in the House of Wisdom, there was a myriad of ideologies, of ideas, of just different things that people were coming up with that were just advancing mathematics and science at that time, more than Western Europe had, because Western Europe at the time was dealing with was really truly dealing with the Dark Ages, which or the medieval ages at that time period. So there wasn't really any advancing of science, technology, or mathematics in that time period for them. But in Iraq, in the Islamic Golden Age, in the House of Wisdom, there was an advancement of science, of mathematics, of technology, to better society and to better people's lives and their livelihood. So again, when I think about what they have contributed, I just find myself being at the end of writing this paper and writing and understanding Arabic mathematics and just being grateful for what they introduced to the world and what they introduced to just mathematics, period. Because I think that sometimes we just take, I think for my generation and even people younger, older than me or younger than me, we take for granted the knowledge that we have. We just take it as, oh, that was always 2 + 2 = 4. It was always like that, but it wasn't always like that. Somebody or a group of people came up with the idea that no, 2 + 2 = 4 because X, Y, and Z, and understanding that and understanding how these people possess that knowledge, and that knowledge is passed down centuries, thousands of years, millions of years to now where we use it in our everyday livelihood. It's just astounding to me, personally, and I just think we just take it for granted. I think my generation takes it for granted. I think a lot of people take it for granted, the knowledge that we have and how the knowledge has been passed down to us. And I just think that I wrote in my paper that I think that in some people understanding where this knowledge comes from and how it came about, it may bring better connectivity from the student to the teacher about these mathematical concepts. Because a lot of people have issues with math, and when you have issues with math in your earlier years, it's very hard to want to do anything math related in your later years of your life. But if some people could understand the history of where this math has come from, understand how it came to be, why it was flourishing in that time period, and what it meant for them in that time period, maybe they would not only just gain an appreciation for the mathematics or the beauty of the mathematics, but they will also be able just to see a different lens and a different scope and a different perspective on what they're currently learning now, and they'll see the importance of it now. Of course, also practicality even now, how, just applying these mathematical concepts to business models or finances or any type of science or research related topics. So, and just understanding that, going back to the Arabic mathematics, I forgot to mention that Arabic mathematics was practical, and that wasn't just because Muhammad al-Kharamzi, but it was just practical in general. There were three things that made Arabic mathematics very practical. That was finger reckoning, that was a base 60 system, and that was also Hindu arithmetic. So with the finger reckoning is basically counting on your hands. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how they counted, and that's how they figured it out. And also, in order to do calculations, they will use a dust board. So they were write on a calculation, and they were having a hard time getting to it or getting the answer from that calculation. They would just erase the dust board. Another one is the base 60 system. Before the revolutionary concepts that were founded in Arabic mathematics, there was an Indian mathematics curriculum that was basically saw as knowledge throughout the whole that time period. And that was that everything was a base 10 system. So 10 seconds equals 1 minute, or 10 minutes equal 1 hour. But what Arabic mathematics came to find was that it was 60 seconds equals 1 hour, 60 seconds equals 1 minute, 60 minutes equal 1 hour. And just that system that now we use today. And then furthermore was Hindu arithmetic, and that was, just again, that was a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, That was the number system that they created, and just implementing that number system into equations, into calculations, and just to everyday life. And I just really like what I did for my research, and understanding Arabic mathematics, and just being appreciative of the mathematics that I now use today and I take for granted. It's giving me a different perspective, a different lens to how I see mathematics now, and I'm just grateful for it. I'm grateful for this research. Again, my name is Jefferson Ridgeway. I'm a junior, and my paper was on Arabic mathematics and their culture group.